Question. DS. N is a two-digit positive integer. If n is equal to 4 times the sum of the tens digit of n and the units digit of n, what is the value of n? Condition 1. The units digit of n is divisible by 3. Condition 2. The number of different factors of n is 9. Solution. Let us solve this DS question using the variable approach. The third expression of digits. If n is a two-digit integer, then n can be written as n equals 10 times a plus b, where a and b are the tens digit and the units digit of n, respectively. Similarly, if m is a three-digit integer, m can be written as m equals 100 times x plus 10 times y plus z, where x, y, and z are the hundreds digit, the tens digit, and the units digit, respectively. Let's apply 3 steps of variable approach. Let us follow the first steps of the variable approach by modifying and rechecking the original condition and the question. We are required to find the value of n. If n is a two-digit positive integer, where n is equal to 4 times the sum of the tens digit of n and the units digit of n. Now, let us modify the original condition. We can write a two-digit number n as 10 times a plus b, where a and b are the tens digit and the units digit of n, respectively. The sum of the tens digit of n and the units digit of n means a plus b, and n equals 4 times whole of a plus b, or 10 times a plus b equals 4 times whole of a plus b. That is, 10 times a plus b equals 4 times a plus 4 times b, or 6 times a equals 3 times b, or b equals 2 times a. Therefore, the possible values are 12, 24, 36, or 48. Follow the second and the third steps. From the original condition, we have 2 variables, a and b, and 1 equation, b equals 2 times a. To match the number of variables with the number of equations, we need 1 more equation. Since conditions 1 and 2 will provide 1 equation each, D would most likely be the answer. Recall 3 principles and choose D as the most likely answer. Let us take a look at each condition. Condition 1 tells us that the units digit of n is divisible by 3 in all the 4 possible numbers, 12, 24, 36, and 48. Only 36 has a units digit that is a multiple of 3. So n is 36. The answer is unique, so the condition is sufficient by CMT2, which states that the number of answers must be 1. Condition 2 tells us that the number of factors of n is 9. Factors of 12 are 1, 2, 3, 4, 6, and 12, which equals 6 factors. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24, equals 8 factors. Factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36, which equals 9 factors. Factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48, which equals 10 factors. Amongst the 4 possible answers, 12, 24, 36, and 48, only 36 has 9 factors. The answer is unique. So the condition is sufficient by CMT2, which states that the number of answers must be 1. By common mistake type, for B, when A or B is reached too easily as an answer, then you have to consider D as an answer. Thus, when condition 1 is easy and condition 2 is hard, the answer is usually D. Also, according to tip 1, it is about 95% that D would be the answer when the value of condition 1 is equal to the value of condition 2. That is, condition 1 equals condition 2. Each condition alone is sufficient. This is a 49-level question. This question applies CMT 4B and tip 1. This type of question frequently appears in recent exams, so remember carefully. Thus, D is the correct answer. Answer D.